Hi, this is Lori, and welcome to my series on the Pico W. Today we're going to be completing our Etch-A-Sketch project. So this is the third part in a three-part series on doing a digital Etch-A-Sketch. If you haven't watched parts 1 and 2, I'll link them in the description below. You'll need to view them for the rest of this to make sense. In this episode, we're going to try to address some of the noise in our drawing on our Etch-A-Sketch coming from our circuit and our potentiometers. We'll also add a nice opening screen to our program, and we'll add a button so that we can clear the screen without having to end the program. Let's get started. Here's our circuit. We've started with our OLED and connecting that up into our Pico in part 1. In part 2, we worked with adding the potentiometers to our project so that we could draw on the screen. And now we're going to add a button to our circuit so that we can clear the screen. We'll connect the button to power and back to a GPIO pin on our Pico, and we'll use a pull down resistor with that. So the first thing we'll try to tackle in this episode is trying to deal with some of the noise we saw when we ran our first initial Etch-A-Sketch program on the Pico. In this one I'm going to try using some averaging. So when you have noise, using averages reduces the noise. So we're going to kind of use a running average of the results from our potentiometers before we actually move our pixel on the screen. In the program here, you can see we're going to do all the same setup as we had in episode number 2, part 2. Here's our function, and then I'm defining another function that we used in part 2 where we were trying to get a good result for our low and high end to scale our potentiometers. I'm going to reuse that function to get an average result for our reading rather than a single reading from our potentiometer. Maybe using an average we'll be able to reduce the noise in our movement of our pixel in our drawing. So it'll be pretty simple. We'll go into the while true loop, and instead of just reading one number, we'll use our average function. We'll read 10 times from both of the potentiometers, the green and the blue, and then we'll take that average value and use it in our scale function to get our X position and Y position on the screen. We'll light up our pixel, sleep just a little, and go from there. So not too much change, just this function that we're going to use to get our data. Let's go ahead and run that and see what it looks like on the screen. There we go. It's running. So let's try some drawing. Now if I go pretty slow, especially left to right, that looks a lot better than the program we had in part 2. Well, you can see there's still some noise, especially when I go up and down. And you can still see it even in the going across. A little bit of jumping. Sometimes we miss a pixel, leave a pixel. And there you can still see the noise. It's definitely better than it was, but it's still not perfect, and I guess that still bothers me a little bit. Still totally suitable just for fun project, but I sure would like to see if we couldn't reduce that some more. So another thought I had was to use a situation where we don't update unless we really have a change. Like we don't want to update the pixel we're drawing unless we really are moving in that direction. So I have another idea for that. Let's try that next. Here's the program using the averaging, which certainly helped a lot, but also this idea of not updating our position unless we're really moving, trying not to update just to the noise in the potentiometers. And how I'm going to do that is going to come past all the stuff we're used to. I'm going to set up keeping track of where we were previously. So we'll have an X position previous and a Y position previous. This is just initializing it to the spot that we are at whenever we start this program. And then I'm going to say unless we move 2 pixels, I'm not going to adjust the position of our drawing dot. And you'll see that that has some implications to the drawing we're going to do, but it's just an idea to give it a go. So we're going to still do our averaging and set our X and Y position just like before. But before we go ahead and light up the pixel, we're going to say only update if we exceed the delta 2 pixels. And then we'll go ahead and update our X and Y position. The other thing, as I was experimenting with this program, I thought of, instead of doing a pixel, how about I do a circle? So we're going to use that ellipse method that we learned about in part 1 of this series. And it's just going to be an ellipse that's 1 pixel in each direction. And I have it filled, although 1 pixel is filled, so it's probably unnecessary to put the true there. And we'll show that and see if that helps us some. And then when we get to the bottom of the loop, we have to be careful to make sure that we take the current X and Y position and set them to the previous, so that as we move around, we'll continue to update our previous position so that these if statements will actually do something. A little more complicated of some code, but maybe this will help some too. Let's give that a go. Alright, so we're on the screen here. And you can see now, because we're doing a circle, we're going to use a lot more pixels in our drawing. So we're getting thicker lines now. Now I did see, as I went up and down, I did see some jumping a little bit. But that's looking nice. And in fact, if we had a bigger screen than this really small OLED that we have, I bet we could make our circle even a little bit bigger, and this approach might make it work pretty smoothly. So that helps a lot. Certainly not perfect, and maybe some additional coding we could try to improve that averaging and this not updating constantly approach. But I think that's as far as we're going to get with this. I'm curious if you have any experience doing this sort of thing, if there are some other strategies. I mean, I've Googled around and tried to find some approaches. Averaging is one of them that people use, and this idea of not constantly updating was another idea that I found out there. But if you have another idea that might make this work even better, I'd be curious to hear it. So please post it in the comments below if you have some other ideas. With that, I think we're going to say this is good enough, and let's go ahead and add our button and our opening screen to our project. I have a program here that just working on trying to get this graphic. I wanted to have it say Etch-A-Sketch and have a little graphic that looked like an Etch-A-Sketch. And I wanted to do it pretty simply, just using some of the methods we learned in part 1 of this series. So we'll add some text that says Etch-A-Sketch at the top. Then we'll have some rectangles. One of them will be filled. And these 2 circles, using the ellipse method, are the little dials. And then we'll show that. And right now I just have this running until we press Control-C so we can take a good look at the graphic. So I don't have the Etch-A-Sketch part in here, just the graphic so we can see how it looks. And I honestly just did this by trial and error. I threw some rectangles out there and then just figured out how to get them centered and the right size by just playing around until I got it to work. Let's go ahead and run it and see the graphic. And there you go. I think that looks, I'm pretty pleased with that, and I think it definitely gives you the idea that that's what this program's going to do. You've got an Etch-A-Sketch, and these 2 little dials are going to be your drawing on it. So I like that. That'll be a nice opening to our program. Well, now here we are to the final program of our Etch-A-Sketch project. In this last program, we'll add in our button to all the other code that we've been creating as we've gone along here in part 3. So we'll import the needed modules. We'll set up our OLED screen. We'll set up our potentiometers, and here's where we'll set up our button. So we're going to put our button On GPIO 15, we're going to use our pull down resistor, and we'll use an interrupt function to clear the screen whenever we press it. And if you don't know much about interrupt requests and functions, take a look at the episodes I did on the Capture the Light game, parts 1 and 2. They go through interrupt functions in much more detail and explain how they work. Well, here's our interrupt function that will clear the screen if we press the button, and here's where we activate the interrupt request using our clear screen function, and we'll trigger it when we press the button as it rises to a 1. Here's the other functions we wrote for scaling and averaging, and the code we put together so that we don't update constantly. And then I've also added in the opening text, the graphic and text. That's going to be on the screen for 5 seconds. You may want to change that in the future. It does seem like a lot when you use it. And then here in our while true loop, we'll have all the same code that we had before. And that completes our program. Let's see the final one run. All right, and there's our nice graphic. And certainly you could put some instructions if you wanted to add to that. I thought about that as well. Let's just try a little drawing. Sometimes the slower you go, the less noise you get. I do think if these potentiometers were actually soldered into a true proto board, I think that would reduce some of the noise in them as well, although I'm not certain about that. But there we go. Our digital Etch-A-Sketch is working perfectly. Oh, we need to test the button. Let's press the button. There we go. And we cleared the screen, and now we can draw again. Excellent. So I hope you enjoyed this project. It was a lot of fun for me, and I learned so many new concepts from doing it. And I want to thank you for joining me.